Get something.
Are you tired?
It's kind of like
I'm surprised I still have listings available. Like, Brandon called out, but I think he was asking for. Do they teach you about migration still? 10. It's like a really good location too. You can include a library.
Yeah.
It's like like using prompts. Yeah, on the top. So you have to type that. Yeah. I think it's because I talked to Tom. I was like, almost over the first of us. 7 of us get words. Yeah. He's good. He's talking. Like, the only reason I brought him on was because we were like, so you're not allowed to use 7. If we can. Yes, can you understand and stuff? How we responses? Earlier, I looked for splits, like 4 counts. Well, then I was all that. Sucks. What is it? Restaurant texting I do.
20 years for conversation. Like triggered.
No, I wasn't triggered by that. I was triggered when he was like, saying Brendan was not good. Like he's like. Being talked about, this is the conversation happening. No more comments.
He texted me like, yeah, it's good. Yeah, I was kind of scared when I was there. So we should lock into it. How to yeah, we should.
Like, yeah, no shit. Yeah, no. Yeah, sorry. So like, I think yeah, definitely start like I don't know if we call the last time.
All right, discussion night. I think so. It looks like. Yeah, I think the culture. Yeah.
Wait for another few minutes. Has anyone started homework 2 yet? Has anyone seen the update I made? It seems like a lot of questions, but I promise the answers are all very short. I'm just trying to, like for each concept, I'm trying to give you a little bit, I'm trying to give you more questions just so that you really understand the concepts well. But it doesn't take a lot to answer a single question. I made them short on purpose. So it seems like a lot, but it's actually not big deal. So I'm trying to drill down the fundamentals right now so that later on when we get into writing and coding stuff, we don't have to slow down as much because you guys already kind of, ideally you guys have already practice the basics here. But also, let me know if it's too much and too little time, because it's my first time teaching. So, and plus, for me, I can probably do homework too in like 10 minutes. But it's different, right, for you guys. And I need to know if it's too much or if it's okay, if it's manageable. And hopefully after today's lecture, you'll be able to do everything in homework too. Also, as a side note, I'm entertaining this idea of releasing an NFT for the class based on how well you do. You get different NFT. For like, people who got A's get like a special NFT, and then people who get B's get like another type of NFT. And I don't know, maybe those who get A NFTs have some perks. I don't know, like I shouldn't say this because it's recording, but it's like that certain website where you can, if you hold some kind of membership, you get to, like DM the creator or 30 minutes Q&A each week or whatever. I'm not going to say the name of the website, it's being recorded.
People who get B's get Solana NFTs.
I actually don't know how to code in Rust, sadly, so I can't do Solana. Just playing with the idea, just so that maybe there's a little bit more motivation to get an A in class. Although most of you have done pretty well in homework 1. We'll see. And I don't know if someone in the future wants your product, you can sell the NFT on OpenSea or something. If I get like famous enough, maybe. Okay. Yeah.
A quick question on the homeworks. Are the grades posted on?
It's on GitHub. So
Okay.
Jordan and Gaurav, they don't have access to Blackboard yet because ITP hiring is pretty slow. So right now, all your grades are on GitHub. Once they get access, they'll be transferred onto Blackboard. Yeah. So GitHub under pull requests, you can see the detailed breakdowns where you lost points exactly. Yeah. And for any regrading questions, email Jordan and Gaurav first, and once and if there's still any concerns, and they will email me or they'll let me know and I'll look into it. Okay, let's get started. Last time we talked about mapping, right? It was a relatively more confusing concept. Did everyone more or less? Okay, so who here thinks they have a decent understanding of mapping and would like to briefly go over it, what it does? Maybe I'll give like participation NFTs too. Yeah.
Yeah.
Okay.
I was just gonna say it's like a one-way system from like an integer to a string where you can assign a specific integer to a specific string, but you can't retrieve an integer by giving a string. It's like it only goes one way, so you can retrieve the string by providing the integer that's already been assigned.
Mm-hmm. But in more general terms, so what's the integer in this case called? A key?
Oh, yes, sorry,
Right.
key value pairs.
Yes.
So the integers are keys and the strings are values.
Yeah. Nicholas?
I was just gonna add that you can't really like iterate through a map on its own, so you need to keep track of all the keys that you have assigned values to then go back to the map.
If that's what you wanted.
Right, yeah. Or when would you not want to do that? Like you always want to do that.
Well, not really, if, let's say for Heather, like your balance mapping or any ERC 20 token, you don't necessarily have to make it digital.
Okay. Thanks for that.
And you said that maps are the only like data type structure in Solidity.
There's also array that we haven't gone into.
Oh, okay.
But it's super basic. It's, I'll talk about it in a bit.
So there is a way for you to store all the keys if you want to iterate later.
Yes, yes, yes. Yes, but the thing with arrays is that, we'll talk about it later.
Okay.
Yeah. Yes,
So is it typical practice to like set all of your key value pairs like manually, or is that like something you would look through maybe or something, or?
what do you mean? Can you specify?
So like in the last class or up here, we have like node 0 is linked to jacket. Like, do you set all of those in your code one by one? Or?
Yes, yes, otherwise, they won't know what 0 points to.
Okay. Yeah.
And I'm not sure if I mentioned this last time, but when you start off, when you declare new mapping, all the values associated with keys are all initialized to their default value. So I know in some other languages, you're gonna have like null or undefined, but in Solidity, it's all initialized to their default values, right? So the default value for an address is the zero address, bytes32 Boolean false, because Boolean underneath is number and 0 means false. Uints and ints 0. So just can one more question. So they're all initialized to default values, right? And this is also why you more or less, well, this is not why you can't iterate through a mapping. So iterating through a mapping meaning going through every single key available. And the reason why it's not possible in Solidity is because when you initialize a mapping, all the keys exist technically. They're just pointing to empty values, right? So it's different from the concepts of like dictionaries and whatnot from other languages where you can have null. Like if you check for null, if something's null, then you know that's not been initialized or written in. Whereas in Solidity, everything exists, so you can't tell if it's like if I'm mapping. So for strings too, string is initialized as an empty string by default. So if I didn't set 0 to jack, 0 is just empty string. How do you know if I haven't set it to anything, or did I just set it to an empty string? Right, like you can't tell. Right, and then it's the same thing with, let's say in a voting scenario. Let's say I'm trying to build a voting system, right? And I'm trying to keep track of the vote of each address, right? And in this case, so we're trying to map it from an address to something. Do you guys agree with that? So I'm trying to keep track of what's the vote for each address. So address points to a vote. So the mapping goes from an address to something. But do you guys think we can use Boolean in that case? Can we map from an address to a Boolean? Why or why not?
Because you wouldn't know if they answered false or if they just didn't answer.
Exactly. You don't know if they haven't voted or did they vote no. Okay, because it initializes by default false for everything. Right. So you can only keep track of who voted yes, but you won't know who voted no versus who didn't vote. Okay. So you have to think of something else, maybe like an uint, right? Maybe 0 means you didn't vote, 1 means no, and 2 means yes or something. Right. So this is something you have to keep in mind when you're designing stuff in Solidity. Okay. And anyone have any questions regarding retrieving a value from a mapping and then setting a value into a mapping? We can still go over it when we're trying to totally fine. So who knows how that works and wants to walk us through it? You can use analogies like the book thing that I talked about, whatever. People on Zoom, you can participate too. Okay,
I think it'd probably be helpful to go over it one more time.
okay, let's go over it one more time, all right? So right here, we are getting a value from a mapping, which we named A, all right? And again, as we said before, in a mapping, everything is so we point from a key to a value, right? And then we can only retrieve a value if we know what the corresponding key is. Because again, the mapping in Solidity isn't iterable. And iterable just means you can go through every single element. But because everything's initialized by default, so you can technically go through everything. But when you can go through everything, you might as well be going through nothing because you're just kind of going through all the possibilities, right? So you have to know the key that corresponds to the value if you want to get the value, right? So it's kind of like a book where you can only if you want to read a certain page, you have to know the page number beforehand, right? So there's no catalog, so you just have to know. And this is how you do it, right? So you retrieve the value by typing the mapping variable and then using this the square bracket operator. So it's called like an operator, and this is also an operator. Plus sign is an operator. So so A square bracket key, right? This basically grabs the value in A that the key points to, right? And then the reason why it's a string here is because we declare the mapping points from a number to a string, right? If it's pointing from a number to a Boolean, then I'm gonna have to type it as a Boolean, right? And if you get the type wrong here on Remix or anything, they're actually gonna tell you the type's not correct, right? And of course, the key also has to be the right type. So so in this case, the key has to be a number, right? So that's how you get the value. And when you want to set the value, it's the same process. So instead of creating a new variable and then assigning the value of that variable to the value of the mapping, you assign a value to this key, the value that the key points to in the mapping, right? So it's just like the reverse of it. So this is read, this is write. Okay. Any questions on this one? Let me know if you have any questions because stuff is going to get serious on the next slide. We're going to do some inception. Yeah. Oh, sorry. I thought you were. Yes.
So you would set up like getting a value first, and then you do setting a value. Like
No.
zero
This is
operation.
just no. You can set it up. You don't have to get it. You can just set it outright, right? You don't have to get it right now. Okay. So also, when you get the value like this, and you modify the variable val, it's not going to modify this. So you have to modify this directly like so, right? You can flip the order that like it doesn't matter. Yeah. Any questions regarding this? No questions. And again, folks on Zoom, just speak up because I can't look at the chat because it hides my cursor. I'm recording. Yes, look at this. Now we have a nested mapping. How good is that? Right, so I told you that it's going to get serious. We're going to start using nested mappings, right? So look at this one. So on the previous slide, we just had mapping that maps a number to a string. But here we're mapping a number to a string. We're mapping a number to a mapping of a string to a Boolean, right? So in the previous slide, a single number corresponds to a single string, right? But here, a single number corresponds to a mapping of a string to a Boolean. And for each mapping, there are a bunch of strings that corresponds to a single Boolean each. Does this make sense more or less? So instead of a number pointing to one string, we have a number pointing to a bunch of strings, and then each of them points to one Boolean.
What would be like a common example that like you would?
Why we need this?
Yeah.
Okay, so let's think of a case where let's say, okay, so remember we talked about putting transcripts on the blockchain 256, right? And when we do that, we said, I don't know if we said that, but let's say you want to design that system. How can you realistically store the transcript of a single student? So first you have to know what their student ID is, right? And once you know their student ID, you have to know which degree, right? Because for different degrees, you have different transcripts, right? And then for each degree, it points to like a single transcript. And in that case, it would be the student ID, which is a number, pointing to multiple degrees. And you can represent the degree with like a number or a string, whatever. So that would be a uint, a number pointing to, but because we have multiple degrees, so we're pointing to a mapping of, so whenever there's a mapping, it means we have multiple keys pointing to some value, right? So in that case, it will be a single student ID pointing to multiple degrees, and then each degree pointing to a single transcript, right? But then because there are more than one, there's more than one student in the school, so we're going to have multiple student IDs, right? So we have multiple student IDs, each pointing to multiple degrees, and each degree pointing to a single transcript. So that will be a mapping of a number, which is student ID, because there are multiple ones, pointing to another mapping of the degree, whatever, however we represent it, and pointing to, let's say, like vice32, a hash or whatever. Does that make sense? More or less? So that's like a use case of nested mappings. Yes, and the way you modify or read from a nested mapping, it's just for every level you go into, just add a new square bracket, right? So let's say I'm trying to read the value of, I'm trying to get what this is. So we just go down level by level, right? So A is the name of the mapping, right? And then in this mapping, we'll have two keys, 200 or 4, 5, 6, 7. Trying to go into 200, so square bracket 200. And then in 200, we have multiple keys again, right? We're trying to go to sigma. Still waiting for the COVID sigma variant, right? And then we go into sigma, we do a square bracket again. And then that will point to the Boolean value of true. So that will be true. And it's the same when you want to do the opposite and set the value.
So that transcript example, you would have the student ID mapping first, and then like that 245, 67, those would be the degrees.
Those would be the student IDs. Because otherwise you would only have like one student ID, but you have multiple. So these are multiple IDs. And then different degree names. And then pointing to at each degree pointing to a single hash, transcript hash.
So if you just did like string val equals A200 and left it at that, would that like give you the list of, you know, delta, omicron, sigma, or do you have to fill out all of the?
You see, it won't give you a string. And this is because if we cover all that and just look at this, this is a mapping, this is not a string. So if you just do A square bracket 200, the type you will get is this. That's the type. You'll get a mapping back, right? So for each square bracket we use, we go down one more level. So you can see A, the whole thing's A, right? And then 200, we kind of get rid of this, right? So now we're left with this. And then we do sigma, we get rid of this and we're left with the Boolean. Right? Does that make sense?
Yeah. So if you just wanted like delta and you didn't want the true or false value.
Well, the thing is, you know, again, when in the mapping, all the keys already exist and all the values they exist. It's just that for all the keys, if you've never written anything to it, they'll all be initialized to the default value. So delta would always be there the moment you initialize the mapping. It would just point to false because it's never been written to or initialized. Yeah, so you know, I didn't write it here, but if I do A square bracket 200 square bracket chase, you'll get false out of it. Because, by default, all the keys already exist. They just point to default values. Any questions? We can spend a little bit more time on this. This is pretty important in terms of building out like non-trivial products on the blockchain.
How many different like mappings can you have? Is it just 2, or can you do like?
You can nest as many as you want, but realistically, I've never had to go above 3. You can have you can have as many as you want. But usually you'll find that like practically you're never going to go past 3.
Because it's gas speed?
No, just because logically, like you usually don't have to go that deep.
Just taking a couple steps back to bytes 32 and hashes.
Okay.
So I say that 200 would map to delta, omicron, sigma. Those would be stored as hashes, right? The delta, sigma, omicron, sigma.
Underneath, yes, it's a hash map, but not to confuse the others without CS background. If you don't have the CS background, ignore this. But yes, underneath it's a hash map. Okay. Yes.
Yeah.
So the keys are hashed. Yeah. Ignore what you just said. Any questions?
So the way this one's set up, you really only are like, it's only really set up to get the like the Boolean value at the third layer.
Yes.
You can't really get anything from the second layer. So
Yeah, you can't, because whenever you have something as a key to the mapping, you can't really say, like, you can't really get it because all the possible combinations exist. Technically, they just point to default values.
Why is it an unsigned integer?
That says so. You can
It's
do,
random.
huh?
It's random.
Yeah, I just decided to make it. You can do whatever you want. It's just an example of like how a nested mapping works.
So you can make a signed integer and still do the
Yeah,
same.
sure. I mean, because I'm not pushing the range or the limit. Like I can do like int 64. This is like way within the range. I just did 56. And in the future, if we have time in the future, we're going to talk about how we can save gas by manipulating this number when we're and how to order the declaration variables to pack things. But if we have time by the end of the semester. But right now, just use 256 for everything. It's totally fine. Any other questions? Who wants to walk through what this does? And I will help you if you just not. Who wants to do it? Gordon wants to do it.
I can do it if you want. So basically what's going on here is that you are mapping unsigned integer to another mapping. So basically you just consider this like a huge list of mappings. And your first one is kind of like a lookup table to get to each of these individual mappings. A mapping is kind of like it's a type variable as well. So just picture a huge list of mappings. The unsigned integer is just like an index pointing to each of those mappings. And from there, like on the bottom there, we are getting let's just say it's 200, for Jack's example bottom. You're getting the mapping with the index of 200 from your original mapping. And so then you're looking into that mapping, which takes in a string, and you're looking up sigma, and that should be returning you true. So essentially you have a huge list of mappings. Each one maps a string to a Boolean value. And so this is expecting you to pass an index, which is an integer in this case. And it's expecting you to pass in a string, which is your final key.
An index, by the way, is what's within the square bracket. We call it
Correct, yeah.
index.
So in this case, I'm calling the index the same thing as the original mapping's key. The index itself is kind of just, it's easier to picture it that way, at least for me, because it's, you know, it's an integer pointing to another mapping. So I think that pretty much covers it though.
Yeah, and then there's a good point that Jordan made. So actually, if I didn't show it, but what do you think for everyone here? What if I changed 200 to 201? What would the value be? Is it different? Oh, what is it?
False.
Why is it false?
Because it's not assigned to anything.
Yes, because again, as we said, in the mapping, all the keys exist. It's just that the values that they point to are not initialized. Right, so for 201, if I do A index 201, I never wrote anything to it. I never defined it. So it's going to be default. And by default, the value that it points to will be the default value. It will point to a mapping. And by default, a mapping that points to a string to a Boolean, again, for this mapping, all the keys exist, right? But because nothing is initialized, so every single string will be pointing to a false value. So even if I never defined A at 201 at sigma. A at 201 at sigma will return false because just precisely because I never did anything. Does that make sense? So right here you can see that I only wrote out what I defined. But for everything else that I haven't defined, they're all kind of at their default value, which is a number 0. And when you kind of get it, when you fit the value 0 into different variables, for the address is 0 address, for Boolean it's false, for numbers 0, for string is an empty string. For mapping, it would just be all of the impossible values, everything pointing to a false. Yeah. Does that make sense? More or less. So this is a little bit harder to describe with the book analogy because you didn't have 4D books, which doesn't make sense. I remember when I was taking CS 104, the C++ class, there was an assignment. They asked us to do a distance calculation of an n-dimensional hypercube. Like, how do you even visualize something that's past 3 dimensions?
So what's like a application of mapping?
So we just talked about it. It could be a transcript thing. So going from a list of student IDs, and each student ID, let's say for me, right? I got both my bachelor's and master's here. So I have 2 degrees. So a list of student IDs, and for each student ID, you can point to a number of degrees, and for each degree, it points to a single transcript hash.
Like a name service.
Not really, not a name service, like a lookup table. And that's what ENS uses, I bet, in the smart contract.
Right.
It's all about the mapping. Right?
Identity to address.
Oh, it's broad, that's one application, it's broader than that. It's again, any type of logical association to associate something with another thing, yeah.
So would you have to create an individual mapping for each degrees? Like for each student ID with an individual mapping of their degrees? Or would you create a mapping for everybody's degrees? And then,
So let's say your case, we point to your student ID. And then you're asking if you don't have a PhD degree, do I have to initialize?
yes,
Right? I don't have to, because if I don't initialize it by default, your PhD degree key will point to an empty transcript hash.
but you would have the same mapping for everybody. It's just, if I don't have a PhD, it doesn't show up, it's automatically false.
Yes, yes. If I don't define something, it is automatically default value. Yes, which works in some cases, and again, if we go back to the voting case, it doesn't. Because how can you tell if someone never voted or if they just voted no? Right? So just like how I said, I only showed 200 and 4, 5, 6, 7, but there's also A at 201, which points to a bunch of strings and points to each string points to a boolean. They've never been initialized. And just like here, I can have like A at 200 at, let's say, alpha, right? There's no alpha up there. I never defined it. So it's gonna be false. So in the mapping, everything that hasn't been written to or touched will all be false or 0 by default.
And why did you have to map like false?
I just did it. It doesn't, I just did it. I'm just showing like you can explicitly say it's false, but if you're wasting your gas because it's false by default, I'm just saying that, you can do that. Because I'm picking Boolean, which only has like 2 values true or false. If I pick the number, you'll be a little bit, I should change it to a number or something. Yeah, but you never have to do it. Or maybe, it was true at some point and then I reverted to false. Any questions? We can spend a lot more time with this because this is important.
Are we gonna go over like how to define one?
Yes, we will.
You just said you'd waste gas. Does that mean like when you're writing something like this, there's like unnecessarily complex that you're wasting gas?
Yes, every single write action will cost you gas. So like, let's say in Chase's case, he said, if he had a PhD degree that he doesn't have, should I initialize it false explicitly? You could, but then you'll be wasting gas because it's already false by default. So you didn't have to do it. You could, but you didn't have to. Right. And we'll go over this. We'll write through some code. It'll be more clear. Right. Any other questions? Just conceptually, how this works. Okay, so we'll come back to this when we're doing things in code, because it's a little bit confusing. Okay, so that was all about mappings, and that was more or less. So we also have arrays, which I'll talk about later. It's way easier, but that was more or less all the types of variables you'll ever encounter in Solidity, which is a lot less than any other language. Like in Java, C++, whatever, you have like queue stacks, a bunch of trees, a bunch of lists. But here, that's all you have, right? The simplicity of it means it's harder to make mistakes, but it's also harder to write anything because it's like you're given a bunch of screws to build a car or something, right? But on the other hand, anything on chain should be as simple as possible because every single action, write action, when you're writing something to the blockchain, it costs you money for computation and storage, right? So the goal is to keep things as simple as possible on chain. Okay, so let's talk about what functions are, right? So functions, if you know math, you can think of it as in math is like f of x or whatever. But in computer science, it's just a reusable collection of related but smaller actions. So we can say, so let's say starting your car is a function, right? So what do you do every day when you start your car? You walk to it, you open the door, sit in the car, close it, start it, right? But instead of, let's say you're programming the matrix or whatever, right? Every time someone wants to start a car, you don't want to copy and paste all the individual steps. Instead, what you do is you package the individual steps into a single function. You just repeat calling that function instead. Does that make sense? The concept of it, right? So it's like, so we humans actually do it subconsciously every day, right? When I say, I don't know, let's say you're in elementary school and you ask your teacher if you can go to a restroom. You ask, can I go to the restroom? You don't say, can I walk out the door, walk down the hall, turn right? You don't say that, right? You just say, can I use the restroom? And using the restroom, that phrase is a function that encompasses a list of actions that you implicitly you implicitly assume that the other party also understands, the meaning of that function, the definition of that function is the same in your mind and in their mind, more or less. Right, so it's just a set of actions, and then you're kind of abstracting it into a single phrase. That's what a function is. All right. Any questions on this, on what a function is, more or less? Okay. So functions, so a few things a function can do. Functions can manipulate variables, and they can also call other functions. All right. So let's actually skip this first. Yes. So this is more or less what a function looks like. So start car function, you walk the car, open doors, blah, blah, but you notice these individual steps are also functions, right? Because walking to a car, we can define that function. That'll be taking like X amount of steps in X direction, right? And you don't say that. You don't say, you say I'm walking to my car. I don't say I'm walking like 13.5 meters, whatever, 270 degrees northwest or whatever. You don't say that. You just say I'm walking to my car. So, every single sub-action can also be a function. So the point is a function can call other functions. All right. And and let's define it in Solidity, right? So this is what's called a function signature. This is how you define the function, and you see a bunch of terms that, and we'll get into it, right? So first you have function, right? That just defines, that just tells the program that this is a function, right? And then start car, just like the variable name, right? This is the name of the function. You can name it again. You can name this whatever you want. It's totally for your understanding and for other humans' understanding. As far as the computer's concerned, they don't care what you call it, right? You can call this function blow up car, but within it are instructions to start a car, like the computer could care less, right? The pair of parentheses here, it defines a list of parameters that the function can take in, right? So parameters are basically outside information that you want to make available within the function. Now, if we go back to our code thing that we did a while ago, right, last time, you can see that for our get function, right, this is the parameter. This is the parameter, right? So because in the get function, we're trying to retrieve a value from the mapping. And in order to retrieve value, what do we need? A key, right? So in order to retrieve a certain value, we need this corresponding key. But where do we get the key, right? We get it from the parameter. We get it from the outside. And how can you tell the function what the key is, right? How can you introduce outside information into a function? You do that by passing it in as a parameter, right? And we can see that when we're calling this, let me deploy this. When we're calling this, you see that we're able to define what this outside variable is, and the function will do work depending on what we give it. Right? Well, it's all zero because it's a new one. Right? So that's what a parameter is, more or less. It's like f of x. F of x equals blah blah, and x will be the parameter, right? So then you would have the value for, so f of x is like a general expression. But then when you want to plug in precise values, you go f of 1, f of 2, right? It's the same idea. So x will be a parameter. Does that make sense? So let's say, let me open up. Let me just type it. So let's say f of x equals x plus 100, right? And I want to ask you, what is f of 10? Okay. So in this case, f of x will be, the x in f of x would be the parameter. So f of x equals x plus 100, I can just translate it into a function. So it'll be function, I'll just call it like math stuff, all right? So I'll take in a uint x and then returns, it'll be pure as well, because it doesn't have anything to do with logic. No, I'm just returning x plus 100. Right? So this expression here, f of x equals x plus 100. This is the function form. This is what it looks like in code. Right? So the x will, so when you do f of 10, what you do is you plug in the 10 here, which replaces the x here. And this is what you do in the function too, right? If I can call math stuff with the value 10, right? If I call it with the value 10, then I replace this with 10 and I get 110 return. So if you plug in 10 here, then f of 10 actually equals 110. Does that make sense? Any questions regarding this? This mathematical analogy? Yeah.
Did you have to set up that function first and then on a separate line, put in 10?
Yeah, so I can either call it like so. Here, I can do like, let's do 10, right? You see I get 110 back. Or I can call it from another function, but it has to be public, which we'll talk about in a bit. But let's say in test, I do return math stuff. I think I have to actually. Oh, right, I can't be sure. Can I? Okay. See, if I call test, it'll give me 110. Why? Because in test, I called the math function with a parameter of a parameter of 10. Right? So it's going to call this function, plug 10 in, and return this. So you have to define this first and then call it. Just like if I just asked you, what is, like without telling you this, what is f of 10? What are you going to ask? Like, what is f? Right? Just like how you have to define this first. And then you can ask the relevant question. You have to define what the function logic is before asking, what can I, like, what's the return value? Right? It's like I'm saying, let's do this. And you're gonna ask, what are you trying to say? Like, what is this? Right? Then because I have to tell you, like, what does this mean? Instead of I'm gonna say like, let's do, let's work on functions, and then you'll know like what I actually mean. But I can't just say let's do this, and you don't know like what this is. So you have to define the expression first before plugging in numbers. Yeah.
So I guess I'm noticing you always have to declare what type of like value input you're passing in. So in that case, you're saying, you had 256, but if it was a string, you'd say like string space X type thing.
Yeah. So in a programming language, you always have to, you have to explicitly tell it what's the type of the thing that you're trying to pass in. So these are necessary for strongly typed languages, meaning that you have to tell it what type it is. There are non-typed languages like JavaScript, which you don't have to tell the type, but there's a joke in JavaScript. Jordan, do you know the joke about like 1 + 1 + 0 equals, like in JavaScript?
How about just 1 + 1 - 1?
Yeah, so what is it equal to?
10.
10. So how does 1 + 1 - 1, how is it equal to 10 in JavaScript? Because, so let's write it out. So in JavaScript, 1 + 1 - 1 sometimes equals 10. Why is that? Because for the first two ones, it's interpreting them as two strings. So a string 1 plus string 1 equals string 1 1. Do you agree? You're just putting two characters together. But then it starts to interpret it as numbers. 11 minus 1 is 10. So you get 1 + 1 - 1 equals 10. It's just a joke, right? But but it's something that's totally possible in JavaScript, right? And one thing that I like about type languages is that it prevents you from making mistakes like these, and it's a lot more clear about the intentions and logic of the code, right? It might be annoying at the beginning, like you having to, like, it's like I'm saying, the speed limit, which is a non-negative number, is 65 miles an hour. It gets annoying at first, like every time you want to introduce something, you have to tell it what the type is. But as you go along, you'll start to appreciate it and you'll get used to it. Because again, the computer does not have intuition. It just knows ones and zeros. Humans have intuition, computers don't. So we have to spell out everything for them. And when you try to make them try to infer stuff, things like this happen because, you know, actually the hardest challenge in artificial intelligence is teaching AI common sense. Because who here can define what common sense actually is? Right? You can't define it, it's just common sense, right? So you know, computers, you know, you can't expect computers to have the intuition that we do. So you have to tell it everything very, very explicitly. All right. So any questions on this part here? Yes? No questions? Okay. So let's go back. Okay. So that was about parameters. We kind of went off topic a little bit. Okay. So that was parameters, right? And you can have multiple parameters separated by commas. So if you look back, I should have kept the sharing actually. So if you look at the code that we did again here, you can see that for the set function, we have two parameters, right? We have the key and the value because in order to set a value, you have to define where it's at, like which key it corresponds to, right? So we're taking in two and you separate them with a comma, all right? And you can have as many as you want. And that's as many as you want for now, right? Solidity actually has a limit, but we're going to talk about it later on. Okay. I have a quick question. What does it mean to return? Okay. It means, if you remember from last time, it means to return whatever value that's at the key that the key K points to in the mapping A. So remember the analogy from last time about a book, right? So A is a book. The key, K, which is the key, is the page number. And what we're returning, what we're saying is return whatever content that's at this page within this book. So it must be mapped for you, right? Okay. It doesn't have to, all right? So again, all the values are by default initialized to the default value. So if you never mapped it, so in our case, we're jumping from a number to a string, right? And if you never mapped it and you just try to return it, it's going to return you the default value, which is an empty string. Does that make sense? Let me know. Okay. Cool. All right. So next, I have something here called only owner. And this is an optional thing, right? You don't have to have this. This is what's called a modifier. And we'll explain what modifiers are in a bit, right? But let's keep going. Public, right? Public. So the modifier is optional for each function. You can have it, it's up to you. And you actually have to create those modifiers. There are no built-in modifiers. Right, so we'll talk about it in the next slide. So, but public, the visibility, it is necessary for each function, right? So it means who can call it, and we briefly went into it last time. So there are 4 different visibilities in Solidity. There is external, and actually, let me show you here. Let me show you in Remix. Okay, so there's external, all right? Meaning that only people from the outside, people outside of the function can call it, right? And take a look at what happens if I try to call the external function from within. you can see there's an error. Okay. Okay, you see it says undeclared identifier because the external function, it's not visible to other functions within the same contract. So you see here, so you see how in order to call math stuff here in test, I had to change it to public. What if I change it to external? See, undeclared identifier, right? Because external means that the function can only be called from the outside again, and it becomes invisible to other code within the contract, right? So that's why I had to change it to public. And public is like the broadest visibility. It means it can be seen both from the outside and from the inside, right? And please. And the other two are internal and private. So let's change this to internal. So, okay, so before I do that, this is the current version of our contract. You can see there are 4 functions that we can call from the outside. There's set, get, math stuff, and test. All right, let's change math stuff into internal and then deploy a new one. Right, this is a new one. You can see that math stuff is no longer visible from the outside. Right, so internal means that it's only available, it can only be seen from within the contract. It can only be called by other code within the contract. It cannot be called by users for outside contracts. All right. And there's also private, which is more or less the same, right? If we do private and we deploy, right? It's the same as internal, more or less. So the difference between internal and private has something to do with inheritance, which we'll talk about in the future. But for now, just know that if you want something to be seen only by outside contracts or users, use external. If you want something to be seen both from the outside and from the inside, use public. And if you don't want anyone from the outside seeing your function, then use private or internal. And also try to make, so if you have a function that's public, try to make it external. The reason being external functions are cheaper than public functions at compile time. It's cheaper than public functions, all right? And actually, if I, let's see, I change it to public. Okay, it doesn't work. Yeah, so just think about it when you're writing stuff. So, but if you want to play it safe, because we're learning about this, we don't have to care too much about gas fees. You can just make everything public, that's totally fine. In the future, when you see that your public function isn't being called anywhere else from within the contract, just make it external, right? Any questions on visibility so far? No questions? Anyone from Zoom, any questions? No questions. Okay, then let's keep going. Right, so that was a visibility of the function. Returns something, okay, so this indicates what the return value of the function is. Right? So you're seeing a pattern here. Every time we want to, okay, which visibility is the most common? There isn't a good answer to it because it depends on like what you're talking about. So let's say I don't think there's an answer to that. If I do answer it, like I'm going to get into too many things that we haven't covered, so it confuse everyone. But there isn't like a most common visibility. It's just, you know, they have different purposes, I guess. And you can also, you know, when you mark something public, external, internal, you know, you make your intentions clear. So let's say why should you mark something internal versus public, right? Because they can both be accessed from within the contract. Well, you have to think, should any outside people just call that function? Like, is that your intention? If it's not, then make it internal, right? So it all depends on what you're intending to do. Right, so there's no like, there's no such thing as like what's the most common visibility for this. it's like, what's the most common, like what color do people like most? Is there one? No. But you know, there's no such thing, right? All right, so let's talk about return values. And I was saying, as I was saying, you're seeing a pattern here, right? So whenever you're trying to declare a variable, trying to bring something as a parameter, you have to define the type and then the value, right? So it's the same thing here. The type and then this is the variable name that you can actually, you don't need this, this is optional, right? So the important thing is to return type. And you can actually return multiple values, and I'll show you here. Let's see. So let's go to remix again. Delete. Okay. So the test function, let's just return. So right now the test function returns 10. Does everyone agree? It just returns 10. It's pretty straightforward. In order to return multiple values, just add a comma, and I can say it can also return. Let's make it return 2 numbers. And what you do is you should return 10, comma, let's say 20. And now it returns 2 numbers. And if I want to call it, I'll test. You can see that there are 2 return values, right? And they don't have to be of the same type. I can return a number in a Boolean, right? Redeploy it. See, now it's returning 10 and false. All right, so you can have multiple return types, and they'll be returned in like a group. We call it a tuple, but it's basically like a. You can think of it as a list, right? I can return a 3. The spacing doesn't matter, by the way. It's just like. So now we have 3 return values, all right? And but we can also name those return values, and that's why in the slides you saw I was returning bool success or bool whatever. So I can say bool success, right? Now if I run this now, it should on the output side it should tell me like should be named. You can see the only reason to have a something here is to kind of tell whoever is trying to read your output what the value actually means, right? Let's say you have like let's say you have multiple return values. So I have bool success. Let's say we're trying to what's a good example? Weather, maybe like bool is raining, bool is windy. All right, maybe. So if I just let's say it's true and false. Okay. Now if I do this, then you can see that the intention is clear. Like what I mean is clear. Is it raining? It is raining. Is it windy? No, it's not. But if I get rid of these, I'm just going to return true and false, and you don't know what I'm talking about, right? Like if I delete the namings. And you can see I'm returning true and false. What does that even mean? Right.
So if you have like is windy or is rainy, are those callable variables in other parts of the contract, or is that just?
They're not callable variables. They're only there to name your return values, to give them a name. So just to tell whoever's calling it what it actually means. Okay. And usually the caller would be like some front end framework, not another contract. Yes. And there's another way to return a thing. So if you name things, is raining, it's windy. You can also, instead of using the return keyword here, what you can do is you can do is raining equals true, and then is windy equals false. And you don't need to return, you don't need to actually write return. You can just define these variables and it will automatically be set here as a return values. So this is like another way of kind of returning things, but without using the return keyword. Does that make sense? Any questions? Questions? No questions? Please speak up if you have any questions. Okay, no questions. Okay. Yes.
Regarding modifiers, like what happens if you put a modifier or like you forget a modifier, like pure, for example? Like it's not necessary. I mean, you should put pure because it's not interacting with the blockchain, but if you don't, do you get a, does the compiler get mad at you, or are you still able to have that function and still gonna run? You don't have a pure keyword.
It's gonna warn you, but it's not gonna stop you from doing it.
Okay.
And there's another thing. So if your function does not write to the blockchain, it only reads from it, but you don't mark it as view or pure or whatever. I think in the front end framework, when you're executing it, if you don't mark it as a view or pure, it will try to submit a transaction. Yeah, so that's not good. Which means it'll cost you money, although that transaction is totally meaningless because you're not writing anything. But it's going to still generate the transaction because you didn't mark it as view or pure. So it doesn't know if you're actually writing to the blockchain or not. Any other questions regarding, so this entire thing, so this entire line here, this is what we call a function signature, all right? And if you guys remember from last time, I was able to have two functions with the same name coexist, and that's because the name doesn't define the uniqueness of the function. This entire signature does. And the way that Solidity knows which function we're calling is, so the function signature is generated by hashing this line and then taking, I think, the first 4 bytes or something. So that uniquely identifies your function, not the name. So you can have the same name but a different return type, and Solidity will rightfully think that there are 2 different functions. All right, so I can just show you right here. I can have 2 functions with the same name. So I have test here, right? I can have another test. I can even have the same, I can have external pure, but let me just make it return a single boolean instead of 2 boolean. Okay, same parameter groups. Let's see. Okay, I was mistaken. So the return value actually isn't counted. Okay, there we go. So my bad. So the return value isn't counted, but so just this part is, right? So you see that I have 2 functions with the same names with different parameters, all right? And they're able to coexist. Usually these aren't a concern, right? You don't have to think about this because usually when you're writing stuff, you try to name things differently so that people don't accidentally call one over the other, right? But there are times where you would have conflicting functions and you'll have to deal with it, and that's like more advanced, and we don't have to worry about it, right? Okay, so let's talk about, any questions on the definition of the function, more or less, function structure? Yes.
Are the parameters like predefined that you select from, or do you create the parameter?
You create. Well, what do you mean predefined?
Like is only owner like one that like is?
Oh, okay, yeah, we'll talk about it in the next slide. Yeah. So only owner is what's called a modifier, and we define it ourselves. Yeah. So modifiers, right? But any questions on this part? Any other questions? No questions. So what are modifiers? So the only owner thing that we said is a modifier. What does it mean? A modifier is also a function, right? And it's a function that gets run before your actual function gets run. So it's kind of like a pre-flight check almost to check if certain basic conditions are met before you actually get into the logic of that specific function. All right, so let's say there's something called, let's say the only owner thing that we talked about. All right, so this is a modifier. And you can see that the formatting is bad here, but you can see, so for every semicolon, just start a new line, okay? So two things. So the first one is something called require, right? So the require statement, basically, the require function takes in two parameters. You see there's a comma there, right? So the first parameter is an evaluation that returns a true or a false, right? So it could be if one thing is equal to another, could be like if a number is bigger or whatever. So anything that returns true or false, it can take in as the first parameter. And the second one would be a reason, right? So if for a require function, if the first parameter returns false, the entire transaction will revert. All right, and when it reverts, whatever you pass in to the second parameter as a message will be shown. Basically, it shows why the transaction reverted or failed. That makes sense what it require does. So it's used to check certain conditions if they're true, and it will only proceed if whatever is in the first parameter returns true. Right. So in this case, we have a variable stored in the contract called owner, which is an address. So message.sender, message is a special global variable that's available with each transaction, right? And within the message variable, you have different members like message.sender, message.data, that kind of stuff, all right? But usually what we work with is message.sender. Message.sender returns an address, and that address is wherever the call came from, so who the caller is. So this only owner access modifier is checking if the caller is the preset owner of the contract. All right, and if it isn't, we throw an error saying unauthorized, not owner. And if we do get past the require statement, so by the way, I forgot to say this, but double equals means an equality comparison. Right, so a single equal sign means assigning something to something else. Two equal signs meaning comparing the two sides to see if they're equal. All right. If they are equal, then we return true. And if this is equal, so if the caller is the owner, then we go past, then we can proceed past the require statement and into this underscore and then semicolon. The semicolon. What does that even mean? Right. So this is only available within a modifier. This basically denotes the end of a modifier, saying that everything checks out, you can proceed with whatever the actual function is. Right, so if we go back, what this is doing is we're saying the start car function can only be called by whatever owner that's preset. And if it's not, it's going to revert with the message unauthorized or whatever that we define. Right, but if things check out, if the caller is the owner, then we proceed. Does that make sense? And this is useful because modifiers are useful because let's say you have a bunch of functions that you only want the owner to call. You don't want to write the require statement like 2,000 times. You can just, again, it's the same concept as a function. You enclose the logic into a modifier, and then instead of having that line duplicated for every single function call, you just add the modifier here to a function, and then you automatically have that check before the actual function is called. Does that make sense? Any questions regarding modifiers? I named it differently. I don't know why I named it. I don't know why I named it only owner access and there's only owner here. Those are referring to the same thing. Yes.
Do you define the modifier inside of the function or is it
Outside? It's modifiers are special functions. You can think about it like that. Yeah. So you can do everything that you would normally do in a function in a modifier. But it's just that the intent of having a modifier is to do some checks before you run the function.
Okay, I'm getting a little confused with this example, the caller being the owner of the contract. How's that different from the previous slide when you had public versus external?
Okay, so when you have public and external, so they don't really have anything to do with each other. So public and external defines what group of people or entity can call that function to begin with. Right, and so that's only, that's just the visibility, so who is it visible to? Whereas the modifier defines which exact entity, in this case at least, which exact address is able to call it. And this required can, it doesn't have to be, this is just checking for an owner, but it can check for, let's say, a timestamp, right? If the current date is before or after a certain date, you can check that. That's like another common check. Or it could be, let's say in the case of, what is it? Yeah, so in our case, in our product, right? We run like a signature thing, right? So like a signing platform. Let's say the user is able to archive a contract only after everyone else has signed it. Only after everyone has signed it, the user is able to archive. So I can do a require check. Require, and inside of it, I basically make sure that everyone, so the first statement could be another function checking if every single person has signed. And if not, then I revert. If everyone has signed it, then I can proceed with the archival process. Does that make sense?
So you can have a function like, and if it returns true, then you go on, returns false, that's the message.
Yes, that's what required does. Yes. And you will likely, and hint, hint, there is another function that has a very similar functionality as requires called assert. Now you might see assert in other languages too. Assert will also take in a parameter, and if that returns true, then it will proceed. If it returns false, then it would kind of fail the transaction.
What's the reason for like defining this modifier like as its own separate function instead of putting just like the require statement in the function that you want to use? Would you want to reuse this modifier?
Yeah. So let's say you have multiple requires and you want to use it in 10 different functions.
Okay, then you want to make
You don't want to keep copy and pasting.
yeah, okay, that makes sense.
Yeah. So as I was saying, so aside from require, there's also something called assert. It does the exact same thing as require. The only difference is if you fail a require, it will give you back all your gas fees. If you fail an assert, it will eat up all your gas fees. Why? Because it's assert. It's just how it is. Yeah, that's just how they define it too. That's how they kind of made it work. So always use require. So if you fail a require, your transaction, like MetaMask wouldn't even let you submit a transaction, because what MetaMask will do is before you submit any non-view or pure transaction, it would do something called a dry run locally. So it would simulate it running to see if it, at least if the simulation works out, right? So basically running it, like fake running it to see if it works, right? So if it fails the require in the fake dry run, then it wouldn't even let you proceed. I don't think it will, yeah, I think it's the same case for assert, but the point is, like, if you're custom calling something, like if you're calling another contract in code or whatever, and the MetaMask protection isn't there, then if you fail require, it's going to revert everything and refund all the gas you use. But if you do an assert, it will just eat up all your gas. And basically you're scammed out of the gas in your transaction. So that's the difference between the two. You don't have to worry about the cert. I just have it in a homework just so that you guys know that it's there, but you'll never use it. I don't think anyone will ever use it outside of testing. Any questions on modifiers in general? So the concept is very simple, right? It's just a function with some specialized syntax. And what it does usually is to check some basic conditions before you actually proceed with the logic of another actual function.
I don't know if this is helpful to mention for like application purposes, but like NFT drops, like a lot of the time you'll have like a require statement for like being on the whitelist. And they check, like a data structure, like a map or something, that your address is part of this whitelist, so then you can participate in this NFT drop. That's kind of like a very basic example.
Yeah. Yeah, and you can just say that require the value that the address points to in the mapping it's true. So maybe that's a whitelist that maps from an address to a Boolean, right? So if you put your address in, if it returns true, then it means you're on the whitelist. If not, it means you're not on the whitelist. Then, if we have the required statement that checks for that, if you're on the whitelist, then you're able to participate. But if you're not, the mapping will return false, and then the required statement will revert, and you can't get the NF.
Can you use the require statement in an external data structure? So like with whitelist, you usually have to like pay gas to upload an address to the structure to check it. Can you do it where it's just like checks like Amazon Web Services?
Okay. So one of the issues with the blockchain is that it's kind of siloed from the actual internet, more or less. You can solve that problem with Chainlink, but Chainlink oracles, but that's more complicated. We'll get into it in the future. But with Chainlink, you're able to read from traditional web APIs.
It's expensive to upload a lot of addresses.
So it's calling the Chainlink oracle is also expensive.
Really?
Yeah.
You have to spend link.
Yeah, you do. You have to pump your token. And this is also why a lot of NFTs started to do stuff on layer 2s like Polygon. It's way cheaper than the mainnet.
For NFTs, they don't really care what chain they're on, right?
Yeah, I mean,
It's just
People like Ethereum.
it's either Ethereum or Polygon. That's the two. And also there's like Solana. It depends.
because they have most people, but like security wise, they don't really care.
It depends. I think it depends on what you value. But the Ethereum mainnet is quote unquote the real blockchain, more or less. Any other questions on modifiers?
You heard of the Bitcoin blockchain?
It's well, it doesn't support any smart contract stuff too much. So, any other questions on modifiers? No questions. Okay. Anything from the chat? Nothing. Good. Okay, let's keep going. Okay, so this is again pseudocode just means something that looks like code, but it's not really. It doesn't have to be like grammatically correct, right? So that's like the pseudocode for the car function is what? Yeah.
You might have mentioned this, but is only or like in Remix, the ones that you used in there are like only owner of those like default ones that you don't have to explicitly.
Oh, no, you have to. Sorry, I should have named this like you have to define it. There are no built-in modifiers.
Okay.
Just like how there are no built-in functions, more or less. Okay. There are, but there aren't. Like it's hard to explain. But there are no built-in modifiers. Okay. So let's talk about more keywords. All right. And after that, let's get into writing some code. All right. So more keywords, right? So pragma, you remember that from what is it? So the first line or the second line of any contract. Who remembers what this does? Line 2.
It will run for any version that's listed or above, or previous,
Above.
or, okay,
Above, but without any breaking changes. Yeah. Yes. Yes. So any minor release above 0.8. But it probably won't run on 0.9 because 0.9 is a major release. Right. So pragma, it just defines what version of the compiler you can use to compile this specific contract. Because again, Solidity is a very young language. So between major releases, there are breaking changes, and breaking changes means it could make the new version contains changes that could make your code that used to compile not compile anymore. Like there could be grammar changes or function function naming changes. Yes.
Just a quick question, just to make sure I have it right. So you're not using any modifiers in any of these functions? No.
I can define one, so we'll define it later. Let's finish definitions first. And view we talked about, it means a function that doesn't write to the blockchain, and pure means it's independent. Remember the pure function we had where it just returns 1 + 1, right? It doesn't matter which contract you're in. It doesn't matter which planet you're on. 1 + 1 = 2. Right? Hopefully it doesn't equal 11 unless you're in JavaScript. But 1 + 1 = 2. So it doesn't matter. So it's independent of the blockchain, right? So these functions are called pure. And these you don't have to know for that, right? We'll cover these later. But for now, let's go into Remix. Right, let's open up the mapping contract that we had. Let's write our own modifier to illustrate the point of the modifier and requires, right? Okay, so let's write a new one modifier. And we can name it, what do we name it? Name it key check or something. And the modifier can also take in a value, right? Yes. See, if I just declare an empty modifier without anything, it's going to give me an error saying the modifier body does not contain an underscore, meaning that you never let your code proceed past the modifier, right? So, and then remember again, the underscore means all the checks are done. You can keep on executing the code, right? So let's say for the set function, all right, let's say for the set function, I want to impose a restriction where the key that you provide has to be larger than 10. It's a random requirement, but it illustrates how a modifier works, right? So we can do require, and then we can, so you see the modifier here is taking in a number, right? Because we're taking in the key here. And the modifier we want the modifier to check if the key is larger than 10. So the modifier also needs to take in a parameter, right? So, and again, the naming here, and I named it K here, but I named it X here, it doesn't matter, right? So I require X to be greater than 10, or else key to small, right? And do underscore, right? So does this part make sense to everyone? Yeah.
So you can do it this way, but you could also include it in the signature, right? Or like not.
No, I haven't. So this is a standalone modifier. It doesn't do anything yet because I just declared it. It's like a function. I just declared, but I never called it.
Okay.
So I'm just defining it.
In the slides, it looked like it was on one line.
It was when you're using it, you include it into the function.
Okay.
Yeah, sure. Okay, so right now this modifier doesn't do it yet.
What is the A represent? The A function?
No, that's just the name of the mapping that's just the name of the mapping variable that we did last time. Yeah.
Also, does that like the end of the modifier, like underscore semicolon, does that have to be on a new line, or can that be at the end of?
I mean, like it doesn't matter because for languages like Solidity, the semicolon, like I can do this and it won't give you a warning. It's just for your own readability.
Sure. Okay.
Yes. But for Python, it's different because they rely on new lines. They don't have semicolons.
Okay.
Does this make sense? We're just defining a modifier. We're not doing anything with it yet. We're not including it into any functions yet. Everyone understands what it does? Okay. So now let's impose that limit onto the set function. We want it so that, any questions? Mackenzie?
No, I got it now.
You got it? Cool. Cool. Okay, so let's now include that modifier into the set function. All you do is you just add key check, and then you pass in K, right? So the way it works is we're taking a number and we assigned it to the variable k, right, in the parameter. And you see how our key check modifier also takes in a number because we gotta check the key, right? So we stored the key into this variable and we're passing that variable into the key check modifier. And then the x value here will be equal to the k value here, and then we can check if it's larger than 10. Does that make sense?
Does it matter if you put the modifier or visibility, like the order in which you're putting it in the signature?
I think it does. Let's see. Oh, it doesn't. It doesn't. Yeah. But this is usually like the. Yeah, I don't think it does. But if you, I think the plugin that you guys downloaded, I think it does some automatic formatting for your code, and it's going to order things in a certain way. And it's good to be consistent, too. Right? So, but does this make sense? Passing the value into, passing the key value from the parameter into the modifier to check if it's larger than 10. So let's try. Let's now try to let's delete this and deploy a new one. Let's try to call the set function here. Okay, so let's set the let's just do 1. It's going to fail. Let's do 1 string if it's math, right? If we transact, you see it revert. Okay, VM error revert. You can see that the transaction has been reverted. Reason provided, key too small, because it failed this require. And you see the error message key too small. It's going to give it to you here, so that whoever's calling this can know why it's reverting. Now this error message is optional, but it's always good to have it because you want the people that's calling function know why they fail, more or less, and how they can make it so that the call goes through. Like if you actually want people to use your stuff, right? But if I put 11. It will go through because 11 is larger than 10, right? If I do 10, it's going to fail because 10 is not larger than 10, right? Are you guys able to try this out? Any questions regarding this part? Let me know if you're trying to catch up. We can go more slowly.
Hey, Jack, I have a question.
Yeah.
So if you wanted to write like require X is, I guess, need to be greater than or equal to 10, how would you denote that? You just put an equal sign there?
Just add an equal sign. So this is larger or equal to, this is less or equal to. So the equal sign always comes after the larger or smaller sign. Or in computer science, you can also, so an exclamation mark in computer science meaning to negate whatever value that follows it, right? So if I put this, wrap this in parentheses and add a exclamation mark, it means that any value that, so whatever x larger than 10 returns, it will negate that value. And then that'll be the new value, right? So if I pass in 10 as the x, right? And then 10 is 10 larger than 10? No. But this exclamation mark negates the no, and that no becomes a yes. So then this becomes true. So adding the exclamation mark is the same as doing smaller or equal to, but without the exclamation mark.
Okay, because when I tried to run it with that exclamation mark or with the equal sign after that symbol,
yeah,
I got a revert.
What's it saying?
It just said key too small.
Yeah, and what value are you passing into it?
I tried 10 with that.
You have to deploy a new one.
Oh, okay. Okay.
Yeah.
Thank you.
Because you're probably running the old version. That's why. Yeah.
All right, I got it. Thank you.
Yeah. All right, any questions on this? Okay, so that's it for the slides, but now let's get into, let's write a contract from scratch together. And let's write the transcript thing that we talked about. All right, so just this will kind of show you the structure of a contract. And also, like we're gonna kind of make use of nested mappings, okay? So let's create a new file. Create inside of this folder. Let's call it transcript verifier. And then I'm just gonna copy the first 2 lines over. That's just the license and like the version, the compiler version, right? And first, to define a contract, just type contract and then give it a name. And let's just call it transcript verifier, right? Oh, and open bracket. And everything inside this bracket will be the contents of your function, right? And then stop me anytime when you have questions. If you have questions, okay? So first, as we said, we want something that we want a nested mapping, right? So the first thing to do when you define a contract is to think of, oops, I misspelled this transcript. Okay. So the first thing you do is to think of what's the data structure that you should use. All right, but before that, we should write down kind of what's on our mind, what we want to represent. So in this case, we have a list of student IDs, right? Which that's what we start with. Do you agree? Start with that. And then each ID maps to a list of degrees. Do you guys agree? And each degree maps to a single transcript, right? Right, so so for each student ID, we map to multiple degrees. For each degree, we map to a single transcript. And by the way, double slash just means it's a comment. A comment meaning it's only there for humans to read. Computers will ignore whatever you write after the double slash. Right, you can see it's in green. Okay. Does this logic make sense to everyone? Within a single school, we have a bunch of student IDs. For each ID, we have multiple degrees, and for each degree, you have one transcript. Okay. And let's also make some assumptions. And also in the homework assignment, some questions I worded it in a way where it's more kind of real worldy and less kind of technical, meaning that you have to make assumptions, right? And it's okay to make assumptions, but you have to list them. So here, let's assume student IDs are fit into UN 256. Right? We're assuming they're all numbers, right? And assume degrees fit into bytes 32. And again, remember we can use bytes 32 to store strings, but they have to be less than 32 bytes. So fewer than 32 English characters. Right? We learned it the hard way the other day with Jordan that in other languages, each character can take up more than 1 byte. I should know that because I'm Chinese, but I didn't. And also assume, all right, transcript hash fits into byte string. Okay. So it's the same for homework, right? It's okay to assume things, but you gotta make your assumptions clear. Okay. Okay, so now we have it, right? We have the structure of our mapping. Line 6. It keeps highlighting. I think it's something to do with the Zoom sharing. Okay. So we have the structure, of the mapping, and then we have the data types of the keys and the values, right? And now what's left to do is just to declare the map, right? So mapping. So we first start off with the list of student IDs, right? So what should the first key be? So we're starting off with student IDs, and we're assuming student IDs are UN 256. So the first type should be UN 256, right? And we're pointing it to, so for each ID, what should each ID point to? Right? We said for each student ID, we map to multiple degrees. And what are degrees represented in? They're represented in bytes 32. Right? So we're pointing, so each ID maps to another mapping, and the key of the mapping being a bytes 32. Does that make sense, everyone? Stop me anytime if you have questions. Right? And for each degree, what do we map to? Each degree is associated with a single transcript hash, right? So it's a one-to-one relationship. Okay, so whenever you have a one-to-many relationship, you start to point to a map. If it's a one-to-one, you just point to like a regular type. So you see how when we have, so for a student ID to degree, it's a one-to-many relationship, meaning that for each ID, you could point to multiple degrees. And that's why we're using a mapping to represent the degree. But then for each degree, we're pointing to a single transcript hash. So it's a one-to-one relationship, and that's why we just point to another bytes 32 and not, it just said participants can now see your application. I don't know what it means. But because it's a one-to-one between degrees and the transcript, and this is why we're not using, we're just doing, yeah.
Maybe you mentioned this already. What's our implementation choice for the bytes 32 string?
Because a string is a dynamic array of bytes, essentially, and it's more, and dynamic types are more expensive because you have to keep track of the length separately. But for bytes 32, it's a fixed length, and also it has something to do with how Solidity manages memory. Solidity works with, I think, memories that are 32 bytes. I think the chunks are 32 bytes or something. So bytes 32 fits very nicely into one chunk.
Gotcha.
Yeah, and this is also why, like, sometimes UN 256 is cheaper than UN 4 or 8 or whatever, because it has to pad it so that it fits in one chunk. But if you're talking about the struct, you can pack it. So that's a little bit more complicated. That's like we're going to optimization, right? So ignore that conversation. It's a little bit more advanced. But does this mapping structure make sense to everyone? Any questions on this mapping structure? Okay, so let's name it transcript mapping, right? And you can see here we're missing our visibility for our variable. Now for functions, you have to define visibility. For variables, there are only 3 visibilities instead of 4. So functions cannot be, variables cannot just be external, because it doesn't make sense if you think about it. Like if you have a variable, but then nothing in your contract can refund the variable, then why do you have a variable, right? So a variable can be public, private, or internal. If you omit the visibility, then it will be internal by default. And let's just make it internal. All right. So we call it transcript mapping. Okay. Does this make sense there?
Wait, sorry, why are we making it internal?
Just because it's okay. You can do whatever. I just chose internal.
Okay, but if it's internal, that means like when we deploy it, we can't like set it from the outside, right?
Well, you can't do it regardless because you can't just set a variable. You have to, so this is not a function, this is a variable. And you cannot just set it from the outside.
Oh, I see. Yeah, the function would be external.
Yeah. Okay. So basically, in this case, we'll have, we're basically gonna have 2 functions, right? One function to upload the transcript for a certain, one function to upload the transcript hash for a certain student, and another one to verify it, more or less, to read the hash, right? So let's declare our first function to define the transcript hash. So let's say set transcript, right? We're going to call it set transcript, and we're going to take in. So what are the pieces of information we need to narrow down our kind of our scope down to a single transcript hash? We need, basically we need to navigate through the mapping down to this value here, right? But then how do we walk to that value? So first we need to know which student ID is for, right? So we add a UN, call it ID, student ID. And then when we know what student ID it is, what do we know? What do we have to know next? We have to know which degree it's for, right? So by strictly degree. And also you have to pay attention to how the types have to match the mapping, because we're navigating through the mapping, and then you have to match the types, right? And now we know the student ID and we know the degree. What we're trying to do is we're trying to set this value, right? So because we're setting it, we have to know what it is. So we're also taking in transcript hash, right? And we want to make it external. And we don't have to make it return anything really. Okay. And in here, it's very simple. All we do is, okay, so does anyone have any questions regarding the function signature? Everyone clear on this? More or less? Maybe more, maybe less. Any questions here? Okay, no questions. Okay, so the next step that what we're going to do is we're going to go through the mapping, all right? So transcript mapping. Oops, I just chose transcript mapping. Let me stop this. Okay. So to go down first layer, we need to apply with the student ID, right? So once we give it the student ID, we're now at this layer. Does everyone agree? Yep.
When do you know which brackets to use?
Which one?
Brackets.
So how do they correspond?
Like you're using like the round brackets on top, and now you're using this.
Oh, okay. So the round bracket is what we use for okay, so the round bracket is what we use for function parameters or the mapping types or function calls. The square brackets only used for when you're interacting with a mapping or an array. So there are only two uses for square brackets, and all the other ones are round brackets, are parameters. Right, so we're going, we've got our student ID. So now we've nailed this layer. We're coming down to this layer, right? Does everyone agree? And now we need the bytes 32, which is what is it? It's the degree. Okay, so we just keep going with the bracket thing. Great. Okay, and now we're down to this layer, which is what we want to set. So we do an equal to transcript hash. And that's it. That's how you set it. Does this make sense to everyone? Okay. Make sense? Does it make sense? Yes. So let's write a second. So that was the first function to set it. Okay. Let's write another one for everyone else to retrieve it. So get transcript. And this time we can just copy and paste the parameters, but we don't need the third one. We don't need transcript hash because that's what we're trying to get. All right. So we just need the first two to get us to the transcript hash and all this return. Okay. So it's external again. And this view, because we're only getting it, we're not trying to write anything. Okay, So all we have to do is return, and we can just copy this part. Right, because again, this code here. Oh, it returns, I forgot. Returns a by32 because we're turning the hash. So this code here gets us to the transcript hash. The only difference is up here on line 15, we're setting the existing value to a new one. But on line 19, we're retrieving the existing value. So this is the same as by32 hash transcript hash equals to this, and then just returning the variable like it's the same thing. So this is what we're doing. If this makes a little bit more sense.
Do you need line 19 to return transcript hash?
No.
Okay.
I'm just saying this is the same as what I just had for the one liner. Any questions on this part? No questions. Okay, so it's almost time. What we're going to do is we're going to finish this off with some permission stuff next time. So we'll talk about, because right now, right now we don't have any restrictions on set transcript. Anyone can just come in and modify someone's transcript. So next time we're going to add a mechanism to limit who can call this function. Remember how the only owner thing that we had for the card thing, we're going to implement a variant of that here. So we're going to check who's calling this function and make sure that person's authorized. And if that person's not authorized to do so, then we'll just revert the call. All right. So your work for today is just to, besides homework 2, is to understand this. All right. And if you can confidently tell me how this mapping works and how these functions work, then you're pretty much set for like 2 weeks, because this is I would say a little bit difficult to understand, but once you get the hang of it, I would say you're pretty comfortable with split. Right. So I'll stick around for a bit, but it's 3:50, so I'll have to let everyone go. So I'll stick around for a bit for any questions. Start homework 2. This is not like 256, where you can turn in homework 2 months late. So this class is a lot more intense, because I'm trying to teach you guys something that's practical and not just trivial. Yeah, I mean, the trade-off is that there's a little bit more work to do. Right? And any questions you guys have, post. If it's not a personal question, please post on Piazza with public visibility, not private. Okay, so that if anyone else has the same question, they can refer to your post. Thanks for coming, everyone. We'll be up next day. Happy New Year, Chinese New Year, and I'll see you on Wednesday. Yeah.